Welcome to Seeing the World, Advances in Computer Vision. In this episode, we explore 13 pioneering research papers from October 22, 2025, highlighting breakthroughs, challenges, and the future direction of machine perception. Key themes include fairness, accuracy, and real-world impact, with a special focus on Seo et al.'s work uncovering cultural bias in generative image models. Join us as we journey through the innovations shaping tomorrow's AI. AI systems do not always reflect the diversity and nuance of the real world. For example, image generators frequently portray a wedding in Asia using Western symbols, such as white dresses and tuxedos. Medical AI can exhibit undue confidence in its decisions, occasionally leading even experts astray. The risks are tangible. Robot surgeons may misinterpret scans, and creative tools can unintentionally erase cultural traditions. These challenges are currently addressed by computer vision researchers, highlighting the importance of examining the assumptions embedded in algorithms and understanding their real-world consequences. Computer vision technologies power everything from self-driving cars and smart cameras to advanced medical diagnostics. These systems must not only interpret visual data, but also adapt to new scenarios and make fair, reliable decisions. Recent research targets these urgent challenges, aiming to ensure that computer vision algorithms meet the demands of real-world applications. Today's discussion unpacks these breakthroughs and examines their broader implications, providing insight into how machines attempt to see our world and where they may still fall short. Envision computer vision as a dynamic city filled with diverse challenges and opportunities. Each block represents a specific task, such as facial recognition, 3D scene reconstruction, or medical image interpretation. The continuous flow of images, videos, and sensor data is akin to the city's traffic, unpredictable and ever-changing. Researchers act as city planners, constantly redesigning systems to enhance safety, fairness, and inclusivity. The ultimate goal is to build a city, a computer vision ecosystem where every user and application can thrive. The first major theme is smarter clustering and representation of visual data. Adaptive tensor models, such as those proposed by Chen and colleagues, enable systems to group images effectively, even when the data is noisy or corrupted. Unlike traditional models that rely on fixed rules, these adaptive systems learn grouping strategies tailored to each dataset. This process is comparable to sorting a disordered collection of photographs by identifying subtle, hidden patterns. Such robust organization is essential for navigating unpredictable environments where data irregularities are common. A second key theme involves advanced 3D reconstruction and novel view synthesis. New methods allow for the reconstruction of scenes from limited or dynamically changing viewpoints. For instance, event-based cameras, studied by Pfrommer et al., capture changes rather than static frames, enabling the reconstruction of dynamic scenes. Bowness et al. Introduce real-time filtering techniques that generate clear 3D images from sparse or incomplete inputs. This is analogous to imagining the unseen side of the moon from just a few available photographs. These advances rely on asynchronous processing, allowing systems to handle visual data as it arrives, rather than waiting for complete frames. The third theme centers on multimodal fusion and object tracking. Fusion transformers, such as those developed by Tae et al., integrate data from multiple sources, including cameras, LiDAR, and other sensors, to provide a comprehensive understanding of complex environments. Demler et al. Contribute new benchmarks that rigorously evaluate object tracking performance in chaotic, real-world scenarios. This process is similar to a city's traffic control system, where diverse signals are coordinated for optimal safety. Transformers excel at capturing relationships across heterogeneous data streams, enabling robust, real-time monitoring in unpredictable settings. Among the key research findings, several mini-stories stand out. Chen et al. Demonstrate that adaptive clustering techniques can uncover subtle connections within noisy datasets. Bowness et al. Show that real-time filtering methods yield high-quality 3D scene synthesis even from previously unseen viewpoints. Co et al. Reveal that generative models often default to Western imagery, thereby erasing cultural nuance. Chowdhury et al. Introduce online label smoothing to instill humility in medical AI, encouraging appropriate uncertainty in predictions. Wu et al. Propose human-aligned evaluation metrics, ensuring that model assessments reflect real-world human perception. The featured paper of the day, authored by Co et al., investigates cultural bias in generative image models. The central question is, whose narratives are represented in AI-generated images? The team implements a unified evaluation protocol spanning 6 countries, dozens of categories, and prompts across various historical eras. Their approach combines automatic metrics with a culture-aware, retrieval-augmented visual question-answering system. Importantly, native expert reviewers assess cultural fidelity beyond superficial features. To promote transparency and reproducibility, the entire corpus, including images, prompts, and evaluation scripts, has been publicly released. Co et al.'s deep dive exposes persistent blind spots in generative AI. Their findings show that models tend to default to global North modern representations, even when provided with diverse prompts. Iterative image editing frequently erases cultural nuance, resulting in more generic outputs. Cultural changes are typically superficial, focusing on costumes rather than deeper context. These failures are often invisible to standard evaluation metrics. It is the human reviewers who detect the loss of authenticity. This work establishes a new benchmark for fairness and transparency in generative artificial intelligence. The impact of Co et al.'s research extends beyond technical achievement. The motivation lies in social responsibility, emphasizing the need for AI systems to reflect genuine cultural diversity. Key challenges include designing fair and reproducible tests and translating subjective expert judgments into actionable insights. By releasing all data, prompts, and evaluation tools to the community, the team sets a strong foundation for future work in promoting cultural fidelity. Their efforts inspire the development of more inclusive and globally aware machine perception systems. Looking ahead, the field of computer vision is poised for deeper collaboration and contextual understanding. Future models are expected to interpret context, not merely pixel data, drawing from increasingly close ties between artificial intelligence, physics, ethics, and domain-specific expertise. New benchmarks will better reflect the complexity and diversity of real-world scenarios. Hybrid approaches, combining data-driven and physics-based modeling, are particularly promising for critical fields such as healthcare and autonomous systems. The overarching analogy is one of building bridges, connecting technical innovation with cultural and ethical understanding. In summary, computer vision stands at the intersection of technology and society's future. Achieving robust, fair, and trustworthy artificial intelligence requires both technical breakthroughs and ethical vigilance. The research highlighted by Chen et al., Co et al., Bowness et al., Chowdhury et al., and Wu et al. Demonstrates the breadth and depth of progress. Every listener plays a role, questioning, exploring, and contributing to the responsible development of artificial intelligence systems capable of truly perceiving our complex world. This presentation was synthesized using GPT 4.1 by OpenAI for both summary and narrative. Text-to-speech was provided by OpenAI, while images were generated using Google's AI tools. All content was reviewed by a human expert to ensure technical accuracy and clarity. However, some oversights may remain. References are provided for verification. The commitment to transparency, reproducibility, and continual improvement remains central to this work. Thank you for joining AI Frontiers. To stay informed about the latest developments in artificial intelligence research, subscribe for in-depth explorations of cutting-edge papers. Share your thoughts and questions in the comments and remain engaged with breakthroughs at the forefront of AI innovation. This channel is dedicated to keeping you updated on the evolving landscape of machine perception. In this podcast, we bring you the latest breakthroughs in computer science and AI straight from archive preprint server. From neural networks to quantum computing, complex research is simplified so you can stay ahead. Whether you are a developer, researcher, or technology enthusiast, AI Frontiers provides daily insights. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer. This video uses archive.org content under its API terms of use. AI Frontiers is not affiliated with or endorsed by archive.org.